Hi, everyone. Hi, Alex. Hi, everyone. How are you? Sorry, cutting close to 6 o'clock. I just finished office hours, so. Okay. So my office hours changed this week. I had posted an announcement. In the case of the lab, this week is the last lab. What I'm going to do is in the next few weeks, I will be on Zoom on Thursday evening. And if you have questions or concern about your project, that will be the time that you can find me. It will not be mandatory for our Thursday meeting after this week. However, I will also cover final review when we get to like about week 14 or 13 and 14. I wanted to break it up into two weeks in the lecture session. And if I can cover it all in 1 week, then I'll just give you a week off to study and so on, including the week 15 and wrapping up your project. So let's look at what we have. So check out Canvas. So as far as what we have to do in general, okay, so we are at chapter 13, okay? I am not going to, I was thinking about doing a recursive lab, but I actually wanted, so I wanted you to spend some time working on your project and getting that wrapped up because I know that you have like physics and other classes and things that you are also concerned about. So what I want to do is we are going to do a random number generator this week, okay? And then in the next week, for the lab session, because I move all the lab up by one, I will still hold Thursday. I will be on Zoom on Thursday evening. You're not required next week to attend Thursday evening. However, there's still lecture, and the lecture part is, the content. Some of that will go on the final exam. So, we're going to talk about pointers and arrays, right? In assignment 11, okay? The reason why I was gonna implement a binary tree with recursive functions, but I realized that some of you haven't taken data structure in C++, and it might be difficult for you to understand the concept. The majority of you might have taken data structure course in other languages, but I can't make the assumption for everybody. It has to be equity across, right? So, and the binary tree program usually is a final course project for university. So I thought about it and I decided that I think next week we are not going to do regular lab like what we have done. I want to spend that time to answer questions, or if you have concern or need help or something, I can give you some feedback on your project if you like. So I will be on Zoom like regular time on Thursday next week. And if you want to drop by and ask questions, you're welcome to do that. I would still have my regular office hours. The reason why I wanted to do that is because, it's a dedicated time for this class, and it would be easier for everybody to drop by if they need to drop by. Okay. So that is expected. We still have some lecture to cover in Unit 12. Okay. There is another quiz that's going to come after that. I will post a final review in 2 parts. And I will go over each question when we get closer to the final, like about week 13 and 14. That is the plan. And then I will give you week 15 off to get everything finished. And if you finish early, you can submit your project, but I do not grade your project until the end, because that way I can just update my grade book in that one column. It's a lot easier, and then I can add in my feedback. Um, but if you want me to take a look at your project beforehand, right, you're welcome to do that. And then I hope to have some time this week to talk about your documentation, because it is a little bit lengthy for this class, okay? And I got dropped off with my internet connection last week, so I couldn't explain everything for you. Okay, and so the final exam will be in June, and that is, I think it's like the 10th, something like that. And so by the end of that week, you should have your final grade posted, because I roll into the summer shortly after that, and I have cyber camp, which I do with the high school, middle school, and elementary school students the following week. So I like to wrap up all my grade before I go into the week of the 14th. Um, so if you have any questions, of course, you're welcome to send email, all of that, okay? But I will also post an announcement just to remind everyone, because I know some students get off work late and they try to attend a little bit of the session. So I just want to make sure that everybody's aware. Okay, so I was just saying that in week 11, we will not have required lab session, okay? And I will be on Zoom for lab. So if you have questions about your project or something like that, that will be the time to stop by and talk to me. And, I will have to fix the Zoom link to, now for the lab session, everybody can join. Yeah, it's the same thing. So if you ask questions and somebody's there, they're going to listen to your question. Office hours a little bit different, where I admit one student at a time, or if they show up as a team, then I will admit both of them. But for the regular lab session, when you're there and someone's there, it's like being in class. When you ask a question, um, you know, people will be able to hear whatever. So keep in mind that that's going to be happening. Okay. Let me check the chat real quick. Okay. So, and if you had signed up for skill sets, I think they had activated your account and they sent out a mass email today. And then if you haven't done that and you wanted to do that, you can fill out the form. I'll check the form occasionally, and then I should have access now to the dashboard to be able to add individual students down the line. So, okay, so this week we are gonna look at control structure, and the notes you can find here. It's actually just the presentation, and then the assignment, you can find that here. So sorry, I'm gonna pull up my materials real quick. I'm trying to work on a few things because it's deadlines coming up. So in this particular week, we're gonna look at C comparison to assembly. And then next week, we're gonna emphasize a little bit more on array and how to use array. We did a little bit of it with the safe register in the last lab, or the lab 8. So in this week, we're gonna look at conditional statement, and like if else, and with the switch. And then we are going to look at iterations with your while, for, and do while. I think a lot of students struggle with this because of the branching, having to do proper additions and be able to branch. So we first gonna evaluate it from, programming in C, and then how to be looking at it in the equivalent in assembly. Okay. So conditional statements would be used for decision making. And this is important. You see this from the very basic program to more advanced program. And we would use if, and if would check, it would execute the body if the condition is true, whatever that you put in for the condition. Um, and for if else, if it's false, then it's going to kick it over to else. In the switch with the C is that for the switch case, you would have the case stated, and then it's going to check if it's true, it's going to execute for that case. But then you have to break out of that, right? So it is a little bit more complex. And this would be for programs that you would require like options for the users, right? Where they have a lot of different, an array of options to really choose from. So each of your case is going to be the option. And then with the iteration, it's just allowing us to either have a continuous loop, and then, or we would have a limitation with the loop. With the for, we would have a starting point, an ending point, and then how we would want to update each loop. And or we can have something with a do while. So depending on your program, what the do while is that you would want it to execute something and then to implement the while loop with that. So um, you know, a lot of the times when you're looking at automation, right, type of program, you would see a while or a do while. And then you can also nest, right, your statements into like iterative statement into the conditional statement. So when we're looking at an if statement, an if, right, and then we would have a condition. If this condition is met and it's true, okay, so here is where we would see the branching, okay. In the flow chart, we would display that. So in our pseudocode, we would say if it's true, then it's going to execute here. And if it's false, it's going to go to the next line, okay. So if the condition is true, then it's going to go. And if it's not, then it's going to go to the next line because this one doesn't have an else. So when you do this in assembly, you would think about how to use the flags like negative, 0, positive, right? So for most part, we can check for something like positive or negative, and then we would do a branch with the BRP or the BRZ, and in some case, we can check for both. And if it's 0, then we can have it sent somewhere. And you would do this for something like with input validation, and input validation would be more appropriate using if else. So conditional statement often is used for conditions that need to be met, like input validation. If the user input within this range or this number, right, then it would execute. If the user did not, it would go to else, and then we can send it to, like we would display a string where we would load effective address for the string and then be able to put that string. Okay. So the example of this in C or C++ is pretty easy, right? So in this case, we have if x is less than and or equal to 10, we would have y is equal to x times x plus 5. Okay. Now with this, we can use a compound statement, but when we see it like this in assembly, you know that first you have to introduce 10 to the register. And then once you add 10 to that register, then you can branch. So when you see this, it's a sign. It's going to tell you branch me, right? Like you need to branch. And in this case, we can subtract 10 right? From 10, and if it's equal to 0, that means it's equal, okay? If it's positive, that means it's greater, right? So we can check for 0 positive, as in it would be greater and equal, okay? Now, when you look at this, we've done multiplication before, so we just have to, we load the label, and then we can we would need to say what x would be, and in this case it's also plus 5, so you also have to add 5 into the register. So when you see something like this for the body of the if statement that will be equivalent to assembly, you have to break it up like what we talked about before with the equation. You have to piece it into small subtasks. Okay, otherwise it's going to be very difficult to do, right? So you have to think about putting the 5 into a register, add that, right? And then we want to make sure that we load x. And so because that's our variable, and then we have to find ways to increment it so that way it would represent 2x, x times x, or x squared, I'm sorry, that represents x times x. Okay, so, and then we have to load y and make it where it would all come together. Okay, so now for this one, what you have is you would have 2 criteria if the condition is met. So you have z is equal to 2 times y divided by 3. So with the 3, we talked about how we would divide by 3, right? And so if you then introduce 3 into the register, we would operate the division. So if you write a function for the division, you just call on that function, and then we would load y, and then we also need to have y add twice to represent 2y, and then we would load c. So this alone, right, you would look at 1, 2, 3, 4, at least 6 steps in assembly. Okay, so not that we have to branch here. So if it branch accordingly, you can branch it to a label, and then in that label you would be able to do z. Like I can branch it to do z and then be able to do that equation there. Okay, so any questions so far? Okay, so now here it says that only the first statement is conditional, the second statement is always executed. So we already know the structure of this and see in that it would execute, right, the body of your if statement. Okay, so that would be example of if. So here's another example. Okay, and then when we increment like this for C, equivalent of that in assembly, we would simply would add, right, would take whatever the result for kids and then add it by 1. So that way we would increment it by 1. So you would add 1 to the register and then take that and then add it to the other register that holds the output for that. Okay. All right. So now when you get to the more complex things like this, because I know when you work on your project, sometime you would program it in C++ and see how it would look, and then take that and think about how you would do it in LC3, or you would pseudocode it. So when we do the equal like this in assembly, again, we would then piece it into small pieces. So we would have to introduce 4 to a register. And you wanted to check for the equal like this, then you have to operate the subtraction. If it subtract 4 and it's going to be 0, then you can branch it. Okay, so we can check for 0 if we subtract 4, and we can branch it. Okay, and then this is tied with the or, so you would then have to look at it as a separate part. Okay. So in this one, it's a little bit more complex, and you know that it is C, not C++, that they use printf instead of CL. Okay. So here we would have to say if month is equal to 4, or month is equal to 6, or month is equal to 9, or month is equal to 11, then we would output month has 30 days. Okay. So all of these needs to be branched. Okay. And that means that you would have 4 branches just for this if statement if you are looking at assembly. Okay. And you would then have to be able to operate the addition of the 2 complement of the value. And if all of these are met true, then you would then go to CL. So we can do the first branch, the second branch, the third branch, and the fourth branch to the same label. And in that label, we would do a put of the string. Okay. So at this point, when you look at a C or a C++ or a Java statement, you should say, oh, I know how to do this in assembly. If not, we need to practice. Okay. Otherwise, the project is going to be a treacherous road. Okay. So what I like, what I suggest is that we would start, looking at how you write your statement in C or C++, and then think about how that would be in your assembly. Okay. So let's take a look at your assignment. In the first question, it asks you to describe the use of conditional statement in C programming. And we can take that from the first slide. It tells us that it is a way to make decision, okay, about which code to execute based on the evaluated expression. So if it's evaluated true, then it will execute the body of the condition. It's kind of conditional statement. Okay. And the type of conditional expressions, that's pretty easy also from the first slide, if else, and switch. Describe the use of iterative statement. We saw that also on the first slide. That will allow us to execute code multiple times, ending based on the evaluated expression. For the while, it would exit, right, if it's no longer true when it gets the false condition. For the for loop, right, when it reached the maximum set value, because you have the start, right, the max, and the update, 3 parts. If you look at the C language. And for the iterative expressions, you have the while, the do while, and the for in C. In Python, right, if you have taken Python with me, you only see for and while. You don't have do while. So you see for and while, but no do while. In C, C++, right, you see all 3. And in any form of loop, in condition or iteration in assembly, you branch. Okay? So coming back here, okay, we found the answer on the slide 13.2. And here it shows that you can nest the if. And I think we've done the majority of our labs after like week 4, we started doing branch and conditional and iteration already. So if you still don't feel comfortable, you should go back and take a look at the lab we've done, right? And look at how you would be able to write your conditional and iterative statement. So here it shows you that you can nest the if, and in that, right, for this one, when we look at that in assembly, like for LC3, we would, again, like what we said earlier, we would check for if it's equivalent to 3. How can I check? I put 3 into a register, right? And then I subtract it. And if it's 0, right, because I load, let's say I load X into register 1, and then I would add 3 into register 2, right? And then I make it a 2 complement, and then I add it to register 1, which has X, and then I branch it for 0. So if it's 0, then it's equal, right? Now, how do you treat not equal like this in assembly? So I would then load Y into, let's say, register 4, and then I add 6 into, let's say, register 5. I make it a 2 complement, right? I add the result of the 2 complement with register 4, which holds Y, and then I branch for what? Not 0 though, right? We're going to branch for positive, or, yep, positive, negative, BRNP. And if that's true, I send it to a label, and in that label, I would then do this, right? I would load Z, add Z with 1. I would load W, add W with 2. Okay? All right. So if you look at the next slide, they give you some example there, right? So instead of the 2 complement, you can do a negative decimal like this, where you can subtract. That saves us 2 steps. Okay. So the way that they have this is they would do an LDR 0, 5, and 0. So X into register 0. And they did it this way. When you do a register load, that's an LDR. You see that? Where if you do an LD, it has to be a label. An LDI, it has to be a label. You subtract 2. Okay. The way I approach it is I approach it for the true condition, because you have to execute the if underneath. So the way that they did this is it's going to branch to not true, which to me, then it will be just the next statement. I would branch it for true, where it would check for 0 here instead of negative and positive. And in the true, I would execute the body of my if. Okay. And then the Y, okay, then you would do the str. So why do they do this here? We know that we wanted to make Y is equal to 5, but why do they subtract 1 here? Anybody know? We've done this in lab. So when you store Y, okay, because this is a store, and it's store register to register. So you do an str R1, R5, -1. Why is it -1 here? It's a one below the offset. It's one offset, one less, one down. Okay. All right. So for the if else, when it's false, it's going to go to the else, right? And the way that we can treat this is we can also use the label, send it to else, like not true, and then be able to execute here. Okay. If it's true, then we can action the if. If it's not true, if we use the label not true, we would action the else. And you can use else as the label. That's fine. Okay, so here's the equivalent. So on this one, they load X. Okay. They branch for 0 to else. And if X is not 0, it's going to increment Y. Okay. So when you deal with LDR and STR, you see how it's the way that we use the increment. We talked about -1. And then you would add 1 because that represents this right here. Okay. So the add part is showing us for the increment of the value. The load part here tells us that it's going to be 1 below. Then you're going to store it. If you load, you have to store. Okay. And then here they did the LDR for the Z, which is this part. And then you're going to add 1, then store -2. So if you subtract 1, right, you store. If you load 2, you store 2. I would approach this a little different than the way they have, because this is using the for the load direct. It's not direct load, but it's gonna be registered load register. So they load register to register. Okay. And then they're gonna jump to the end where it's gonna skip the else. Okay. So for the else, pretty much the same process there. So you notice that here when we increment the Z, you have, when you increment it, you subtract 2. Okay. And then you would do a +1, and then you would do a subtract 2 when you store. And that's different than when you decrement of the Z. Okay. So here it shows you the 2 different approach for increment and decrement. Okay. The closest. Okay. So when we're looking at this statement, if X is not equal to 10, if Y is greater than 3, Z is Z divided by 2, else Z is equal to Z times 2. Okay. And in this one, if x is not equal to 10, if y is greater than 3, z is z divided by 2, else, right, z is z times 2. Now you notice that this else is outside, right, of the body. So that's different than the else that's inside the body. Okay. So this represents the else for this if, right? And then this represents the else for the first if. So it's not the same. And the way that they set this is it's the closest associated with the if. So the else should be, if it's close to the associated if, and with your your IDE or your text editor, most of the time it indents for you. So we would indent to represent, right, the level of your condition. Okay. So if we look at this example, and you can do else if, right? And in Python, that would be elif, elif. Okay. Any question with conditions for C? Okay. So let's look at while. We've done some lab that requires the while loop and also for loop and if statement. Okay. So the while, it would just keep going as long, it would loop the body as long as it's true. If it's false, it's going to exit. So execute the body as long as the test evaluates true, as long as the condition evaluates true. So let's look at the assembly equivalent. So here we initialize x at 0. While x is less than 10, we're going to print x. And then x is going to be x plus 1. Okay. So here we initialize 0. We simply clear it for our 0. Then we store it where x is equal to 0. Then we would have a label called loop. We load x, and that x is, so we're going to load from R5 to R0. That's going to be x. Then we want to evaluate for less than 10. So you have to introduce -10 or 10 with the 2 complement. So you have to introduce -10 decimal to a register, which is x. So you would add it with -10. If it's 0 positive, then we're going to go to done. Then we would do a load x again. And then we would have it print put. Okay. Now in between this, we gotta make sure that we convert it, right, to ASCII. That's why they have a dot here. Anytime that you have output or input, ASCII conversion is required. Okay. And then for the next part, we're going to add 1. So increment x. Then we're going to store. And then you have to jump it back to the beginning to test again, to keep going as it would be while. Okay. So the difference between this compared to the last one, if you look at the last couple, right? Let's go back over here. Okay. When you jump this for done is going to bring it to your next statement as well. Now with this is when you jump it like this, it's an unconditional branch. So it's going to send that here But when we jump for the while loop, we're going to have to jump it back to the label for the loop so that way it keeps looping. Okay. In this one, they just send it to a different part of your code. In the while loop, when we jump back to the beginning of the loop. We jump back here. So it's going to do this.
With jump, I know that one is usually used with a register, but I suppose in this case, when you have a label, it's the same as BR without any conditions.
Yeah, you can branch with the label like that, but the proper way is to jump it. Okay. Yes, it would do the same thing if you do a BR loop. But remember, the branch itself should be used with flags for condition, right? Yeah, you can branch it and it will still do the same thing. Okay. It will still send it back. But in assembly in general, when you loop it, you should use the jump. Okay. Whether it's Microsoft ASM, etc. Branch should be used to test conditions. But yeah, in LC3, you have a BR and it would still send it back. Same thing. I think I've done that in one of my lab. I did a BR, but you should jump. Okay. Now, while does, if it keeps true, then it's just going to keep going. And in some program, you would always see that it's going to keep looping, right? It's always going to ask the user for the input, and then it display, and then it's going to come back to that loop again. So we might have a program that has infinite loop. And then in some cases that can cause issues. So, right, it really depends on the objective of your program. Okay, so let's look at the 4. You have to have the starting or the initialization point, the n, which usually is the maximum loop count. Okay, it is the maximum loop count, and then the update portion, how it would reinitialize, and then your statement will follow. Okay. And in assembly, we can still use something like this. So this would be for we're going to start at 0, and then we're going to go I all the way to less than 10. And then we're going to increment I, and we're going to print I. Okay. So we would then have to treat I, right? We would initialize. So your register 0 here represents your I. Then we're going to have to store I. Then we would have the loop. Okay. And that would take care of this part right now. So we would then load I, because that will be right here. And then we would add -10 so we can check for this less than sign, right? So 0p, it's going to go to done. And then we're going to load I, and then for us to print. So ASCII conversion, and then do the put. Okay. Now for the update part, to increment I, you would add 1, then store it. Okay. And so now, why is it a 0 here? Because when we load I, it's just I. So we would then have it with the load 0 here. Okay. I I would approach this a little bit different where I actually would use a counter to count down. So I would then subtract as it count down and then branch it when it reach 10. So either way, you still have to branch in the 10. Um, the way that they use this here is they use to label and then we just check for this part. Okay. I would keep subtracting 1 to really get the update increment for the count. And then when it gets to the 0, then it goes to the next part. So, really depending on how you approach it, you can keep subtracting the countdown and it's gonna, or you're gonna add it. And then when it reaches 10, it subtracts 10, then it's gonna exit your loop. Or you can start with subtracting 10 here, branch to done, and then you would just keep loading the I. Okay. So there's several ways that you can do it in assembly. So here's just some additional example of the for loop, and for loop always have the 3 parts. So Eric asks, is it okay just to use one label for the loop and let the code fall through to the next statement? Yes, that's what I do. and I don't load and store as much because and the way that they use register 0 like that, you have to really copy stuff in order to really with the ASCII conversion to be able to put it. Yeah, you can definitely use one label and then be able to update it right throughout. And as it loops through, it would just count down. You can do it that way. Okay, instead of using multiple label. And then, anything beyond that, it will just go to the next line and so on. It will follow. Okay. So we can also nest. Okay, like nested for loop here. And so in this case, what you would do is if you can't, when you do that in assembly, it's pretty much the same process. It's just using different variable here, right? So you can pretty much copy and paste the code over and then just to be able to nest it within. But this, when it checks for this, then it's going to go to this to check, to loop, and then it's going to print. Okay. So the position of that is important. Okay, like loop 1 and then loop 2 and then done, right? So you can do it that way using 2 consecutive labels. Or you can name it like inner, outer, etc. Okay. So as we were looking at the example, let's do number 5. I gotta recheck this because sometimes I make boo-boo sometimes. All right, LC3, right? We wanted to make a short little brief snippet of the program to represent if X is equal to 4, Y is 7. Okay, and this is my take on it. I did use some of the other stuff that they have there, but okay, origination at 3000. We're gonna do a load X to register 1. I don't like using register 0 too much because I want to reserve it for other things, for in and out, input and output. Then I copy the X, and this is my approach. Okay. And I wanted to subtract it. And you don't have to copy it, but you know, so you can skip this part if you don't. You can just subtract it. Subtract 4. If it's negative and positive, I'm going to send it to not true. And then we would load the label Y. And then we copy. And again, like I said, you don't have to copy unless you're doing something with that particular register as Y. So I copy, and then I would add 7. So Y is equal to 7. Then I do a store from R3 and R4 as I copied it. Okay. And then since I wanted to make sure that I can check it with the input, I do a fill and a .n. So and I didn't have the not true. Well, we don't have to complete, but you would need not true. And I would put ... there. So if it's not true, what are you going to do, right? Go to the next part of the program. So, or halt or something like that. Yeah, maybe we can do that. We'll just halt. If it's not true. So the only label I use is for the not true part. Now you can use like true label where you check for 0, and then in that so another way that you can do this is if you subtract 4, and if it's equal to 0, you can check for 0, you would send it to true, and then in true you would load Y, right? Add 7, and then store it out. Okay, so that would be another way. Question? Okay, so this one you can also refer to number 6. You can refer to the slide in which I did. Okay. So here I put additional comment. So in this one, we did the register load, assume that R5 contains X. And I don't like to do it this way because it's hard to test your program, right? I like to do LD or LDI to the label, so you can use that to set your value, and then you fill it and then you set your value, so you can check to see if your program is correct. But this way is okay as well. That's if you don't need to check. Okay, or you can ASCII convert it. So we would have it go to 0. Actually, when it checks for 0, if that will be true, then we would go to true. Then In the true, we would then load it. True, then we would increment y and decrement of z. Now, if you don't want to make it this way, you can do it like what they did, right? If it's negative or positive, you can go to else. Then you would then take this away, and then your else, you can follow it up here. Okay. Okay. Questions?
Professor, for that one, doesn't it have to branch 0 based on the question that it's asking?
Yeah, well, if you branch 0, then you have to have a label for true. In this one, I branch for negative and positive. Anything outside of 0, it's gonna go to here. But if you branch for 0, I'm gonna write one for the 0 right now. Okay. Sorry, I have to copy it so I can see it. Okay, so if we branch for 0, we're gonna do, let me bring this down to the next page. So alternately, we can do it this way. We would do an LDI R1, let's say X, right? Or LD is fine. And then we would add R1, oops, R1, and we would do a 0 like this, okay? Or you can AND it, it's the same. Okay, then if it's 0, then we need to branch. Okay, then for the else option, you would just then do the decrement, which we would then load LDI R2 is Y. And then we would then subtract, right? Add R2 with negative. Let me double check. Yeah, they just added again for the 1 for cat. Okay. With the 1. And then we would do a Z. And then we would do an increment and R3 with the positive 2. Add R3 with a 1, a 2, right? O2. Yeah, increment of Z, subtract 2. Sorry, I forgot the negative 2 because it's 2 below. And then, so for the true section, then you would do the reverse. So here with the, for if it's true, you and an increment y, and then you're gonna decrement of z. So then you would take R2, you know what? I'm gonna put this up here. Because I don't want it to get hang up in the bottom. Okay, then we can reuse it. So we would then have to get, what is that, add R2 with the 1. Did we have to decrease y? Yeah. With the -1 or with the 1. What did I do here? +1 and -1. It's 2 below and okay, yeah, and then we're gonna store. So we are doing a decrement, so that will be 1. And then we're gonna do a store. Oh, I forgot the Z. So we're gonna do an STI. Okay, so I store here because I have to store out if this is met. But if under the label true, then since I loaded before the branch, I need to store out the Y and the Z under true. Okay. And then you can fill it with whatever address. And you wanted to fill it close to what you have, but you can even fill it at like hex 4000 or whatever. That's near the end. Okay, we've been filling in like close to our program because our program is pretty short. Okay, so you can do it this way if you use the label true, or you can do it like the way that they have it. And in this one, you have to load and store. And if you load it at the beginning, I feel like if you load it at the beginning, you can use the label and then reuse your register. So there are several ways that you can get away with not reloading it every time. But if you reload it this way, what you do is you just updating that for that particular section only. Okay. Okay, so let's talk about the next one. For 7, evaluate the comparable program for C and LC3. Describe how the branch instructions are used to implement while loop. Okay, so you have X initialized at 0. Well, X is less than 10, print X. X is X plus 1. So your compound assignment there. And the LC3 program, here you branch for 0 positive and you're going to go to done, but right before that you subtract 1. So earlier we said that we are checking the condition for this, right? If it's 0, that means it means it's equal. If it's positive, that means it's greater than. So that means that that's going to exit, right? So we're going to get out of the exit. So the branch is used here to check for X is less than 10. Okay, as it would check for 0 or positive after the subtraction of 10 or the add of the negative 10. So we would say that branch is used to check for a false condition after register 0 is added with negative decimal 10. If positive or 0, exit loop, go to label done. Okay. Any question with this? So by now we should be very comfortable with using branch, and branch simply check the line before it, right? So when it adds the negative 10 to register 0, if the value in register 0 as the result is 0 or positive, it's going to go to done, which exits the loop, right? that will be whatever the rest of your program. If it's negative, then it's gonna then do this part right here. Okay. And then we do a jump loop to bring it back to the beginning, and it's gonna keep going as long as it's true. So the branching is used for false, to check for false condition. Okay. If positive or 0, that would exit loop. Go to label done. Okay. So for question 8, it asks you to look at the for loop in C program, write a comparable iterative structure in LC-3. So the first part is we are going to, if we follow the example in the presentation, we would clear, I'll comment that for you. So R0 is 0, right? And then the next one is going to be I is going to be equal to 0, assuming that R5 is I. So that means that what we did here is we would store I to I is equal to 0. So R0. Okay. Then we have the beginning part of the loop. So here you load the I. And that came from register 5. And then we would then add -8 to branch. R0 is equal to decimal -8. And that would give us what? This part right here, right? And we're checking this part right here. So why am I not? So here, if we branch it for positive, that will be greater than 8. Okay. In this one, it actually go to 8, right? Oh, that's right. You branch it for positive, then it's going to go to done. Anything above 8. Because the loop is going to stop at 8, so we're going to branch it for positive. Exit loop. Go to done after 8. Okay, then in your loop body, you would then need to load I. And then here we would ASCII convert. So for the ASCII convert, we can subtract, right, 48. So you can do something like this, R0 And that gives us 30, right? And then 45 plus a 3. You can do it that way, or you can fill it with a certain thing. So here we have 45, and then we just add another one. I'm doing it the long way, I know, like what we did at the beginning. Then after we have that, now we should have negative 48. Then we can do what? We can do a put, right? Which gives us this printf right here. I can't type today, I'm sorry. And then on the next part, we would reinitialize. And then we would add our 0 with the increment of I. And then we would store it. So our 5, which was what, your I, so that's fine. And then we would loop it again, so. Okay. Okay. So for the next question, question 9 asks you, what are the primary differences between do while and a for loop? And coming back to the presentation, you would find that there. Well, for versus. So for loop is preferred for counter-based loops, and while is preferred for sentinel-based loops. Okay. And while would test checks for sentinel value. And with the for, it has explicit counter variable that we use I in the last example. And that would be easy to look at how it would be updated throughout the loop. Now with the do while, the test is then evaluated after executing the body. So for the next question, we can say that the do while test is evaluated after executing the loop body. The for the test is evaluated before executing. Okay, any question? Okay. For number 10, it asks you, what does the following loop do? You have a for loop with a nested if. So the for loop, it starts at 0, it goes up to 20. It's going to update, count up each time with the if. If I mod 2 is 0, then it's going to continue. And it's going to print I. So explain what this loop does for number 10. see what else. Let's talk about this example problem. Okay. Calculating pi. So you would then have the expansion of the series. So you have 4 minus 4 divided by 2, 3 plus 44 plus 4 divided by 5 minus 4 divided by 7, and so on and so on. Okay. You notice the bottom, the denominator would then be prime, right? Or 2 times n plus 1. So you would have to get the user input. So in assembly, when we do this, we would then have some kind of string to display, right? So you would do an LEA register 0 with a label. And in that label, you would do a string. Please enter numbers. Okay. Then take the input from register 0. We would then ASCII convert it by subtracting, by changing it with the ASCII offset, which is 48. Then we would evaluate the series, okay, and then output the result. So that would require us to do this equation. Okay. So the way that they map this is when you evaluate the series, if you look at the equation, you would then have to implement the count. Okay. Check the term and then update the count by 1. So if we look at the C++ program, you would have a for loop. Count is up to the number of terms. And then you would do a count mod 2. And in the mod, we would treat it like a division with a what? With a remainder is going to be stored. Okay, we've done this before with the division and the division program that in the past. Okay. And the way that we see this is pi, right? For the odd term, we're gonna do a subtract, right? And then time and multiply. So pi is gonna be, here's a compound assignment. So we're gonna make sure that for assembly, we're gonna bring this into a register, okay? And then we're gonna subtract it. Then the output of that is going to be put into a register. So then after that, we are going to divide. So now you're going to have to make this into multiple subtasks. Okay. First, we're going to handle the 1, put that into a register. Okay. And then add that with whichever register is going to hold your count. Okay. And then the output of this is in a register. We're gonna, since we multiply it by 2, we're gonna add it to itself. That's gonna make us 2 times count plus 1. Then once we have that, we would tie it back to here. So you would then operate the division, which is giving you the subtraction. But we wanted to transfer the remainder and the quotient when we deal with the division. Okay, so that would be for the if condition. Then in the else label, we would do similar to that, but for the even term without mod 2. Okay. So if you look at the C program, and if you're able to take this and put it into assembly, you're ready. Okay. So in the future, our future final exam, you will be given snippet of assembly code, and you will have to tell me, select the option that would represent, that would describe that code. Okay. It's not too hard. We've done most of the from simple to a little bit more complex program, but you can take something like this or your own program, and you would be able to write the assembly equivalent for it. Then you're ready. Okay. So here's the prime number ones. And then your code. So for the switch statement, you would see something like this, right? In the switch statement, you would have the expression. So it evaluates the expression. If that's true, it's going to execute the action for case 1. If it's not, it's going to go to case 2. And then, but you always have to have a default, and in between you have to break. So if we look at something like this, right? So in the assembly, when you think about the switch, each of your case option, you have to branch, right? So you're going to have to implement branch for each of your case option. And then if you officially wanted to make it like the actual C program, right? We're going to send it to break, and then break is going to take us to the next part of your program. Okay. So you would likely have to use a lot of different labels. You know, you can use case label, and then with that, you can test it with the branches and then send it to another label and so on. So that's another way that you can approach case switch. So like this one, for example. So if you say if switch A, case 1, print A, case 2, print B, C, and so on. So we would then have to bring A into the register, right? And then check for equivalent of A. So branch for that. If that's true, then we're going to do ASCII conversion print. And you know, the way that we would see the character A in the switch is that we would then we can put in the ASCII equivalent or the hex equivalent for it, and then check for the branch for 0 when we subtract. If it's 0, then we can print. If it's not 0, we send it to case 2. Then in case 2, we would check for B. And then if it's equal to B, then we would print. If it's not, right, then we send it to the default, and so on. So this is probably going to take 1, 2, 3, 4, 5, 6, 7, 8 line in C. I would say it probably be like close to 20, a little bit less than 20 lines in ASM, in assembly. Okay, so you can practice and see how you would do with like switch case and so on. So at university, like University of Texas, I looked at their final exam for this class, this exact class, LC-3, organizational structure, right? they use the same architecture. So their requirement for the final project, for the final exam, is binary search using binary tree in assembly. Okay. So here you can take a look at the flowchart, how that would be in like C. But this one is not implementing binary tree though. It's just a search algorithm. Okay. So if you can take this and be able to write it in assembly, right, that will be good. Okay. Any question? So there are a lot of different examples that you can look at and see how you would be able to do with ASM. And just to wrap up, I think my students, sometimes they get confused about break and continue. Okay. For the break, it's used only when the switch statement iteration for the statement. So you would do it in a switch statement. You can break from the program. Like in C++, you can break from the program. In Java, you can break from the program. Okay. So it's a way that we can get out of a certain condition when we use a break. And it's not, I feel like when you use a break in your program, it's not clean. It's, you know, why do you have to break from that? But usually it's often used with like switch or something that you want to get out of the loop. With continue, you would use only in iteration statement, you should, and it should allow you to terminate the execution of the body for this iteration. So that way it would continue to the next part. Okay. So here you can see it. Okay. So I have a little bit of time left. I wanted to touch on your project documentation so we're clear, because I didn't get to do that last time. Do you have any question for me? I was just sitting in the dark. No question, huh? All right. So I hope that some of our practice today kind of help you, okay, with some of the parts in your project. Okay. Keep in
Hey,
mind that you're, yes.
For that example, so we're gonna be like increasing the loop, and then that mod sign means we're dividing by 2.
Yeah. So you have to divide it by 2, but with mod is the output is going to be the remainder, right? So so when you mod 2, that will be even if it's 0, right? If you have your output is 0, that will be even. So in this case, if you mod 2 and if it's not 0, then it will be odd, like a 1. So if I take 5 divided by 2, that will be 1 because it's an odd number, right? So you would then divide it by 2 and then store, and your output, your remainder is what you wanted to check whether it's 0 or positive. Okay.
Also, that print F, it's printing what the remainder is, and then it's printing the value that we inputted for I.
Yeah.
Okay.
So this is going to give you the C out, right? And then it's going to give you the I. Now, with the mod, we've done like division where we store the remainder, and we've done mod too. We did it last week when we did mod 7. Okay, when we convert the month, the day, and the year. using Zeller formula. Okay. So if you wanted to look at that mod section, you can go back and take a look on how we've done that. So basically we divide it by 2 and we treat the remainder. We keep the remainder as the result, and then we use whatever that register holds. Then we would check, we would branch for 0. And in the case that it's 0, then that's going to be even. Okay. Let's talk about our project. Is there any other questions regarding iteration and condition? So one of the things that I didn't get to touch on about your project is your documentation. Okay, I see a chat question. Okay. Yeah, so in a way, when Eric is right, and I know LC3 is a little harder, okay? So think of LC3 because it's low level, it's gonna be small pieces at a time, right? It's like when you're teaching a language to little kids. In LC3, you're gonna have to break it up into like a whole sentence into portion of a sentence. Okay, so in C++, when we look at an equation, we can incorporate the equation, the library, everything, and the compiler handle all of that. In LC3, when you're looking at an if statement or a for loop, you have to make sure that you piece that into small pieces. Okay, so before we get into this, if you look at this statement right here, you have to first say, oh, in C++, we should say, oh, there's a variable, it has 0. Yeah, and then it's going to go up to 20, and then we're going to update it. So first in LC3, we're going to have to make this, right, a 0. Then we have to use branch for this. So that's another line. And then we gotta bring this in, and we're gonna subtract it so we can branch, right? So that's like 2-3 lines there. And then we would then need to increment this. So instead of writing it to one line, you have to piece it into small little pieces in order to get that complete statement set up. Okay. So if you can think of it in small subtasks like that, right? When you look at this, you say, oh, I need to put I into a register and make sure that it is 0. So I just clear it. Then I gotta bring 20 into a register and or subtract 20 from a register that is I. And if it's, if it's greater, if it's a positive value, since this is less than an equal, then it's gonna exit out of that loop. So I would send it to exit and then I would do an update. Okay. So when you look at that statement, you should be able to piece it into a few lines of assembly each. Okay. And then again, this part too. Okay. You're going to take this and you say, oh, that's a mod 2. So I'm going to divide it by 2. But in order to divide, I'm going to have to subtract and make sure that I keep the remainder, and then use that remainder to check it with 0. So I would then branch it and have it check for 0 and so on. Okay. All right. I hope that helps. Okay. Let's talk about the project. So the documentation for this is a little bit longer than most of my other classes, because many of you, this is going to be your last stop before you get to university. Okay, and this is one of the harder classes. So, and then if you're taking this class before you're taking advanced power programming, more power to you, right? You understand assembly before you understand other stuff. That's great. That's great. That's fine. But for many of you, you usually take CIS11 that you need for transfer or something like that. So that's why I require a little bit more lengthy documentation. So in any form of documentation, some professor, they would require you to write an executive summary along with your thorough documentation. It really depends on the professor. But what I did was I already established a template for you. You just have to fill in the purple section. When you write your documentation, you should always state the purpose of your program, including putting stuff on README, right? On your GitHub, when you put together documentation for your program in the read.me file, right? State the purpose of your program, right? And when we started this class, I put in the comment at the top so that way you know the proper way to really look at the program, and that's going to help you document it. You're going to put in the type of input that you have, the side effects, the limitations of your program, and so on. And sometimes you you even have to state like some basic procedure. Some professor, they would require that. Okay. I don't for comments. I really think that comments should be used lightly throughout, but some professor, they want that at the beginning. So documentation allows us to really document thoroughly the functionality of your application or your program. And here I want you to state who's your intended user. So if you're doing the grade calculator, think about who's going to be your audience, who's going to be using that, right? Is it the students that can check their score? Is it teachers? Is it school administrators, etc.? All right. So think about the audience, put down the type of audience. Here in the scope, you would need to put the intention of your program. And so here's the example for that, right? Like this is for a system and how it's integrated and how it should be used with some of the features and how that's going to be scaled. So scope should it should entail a little bit of the objective, and it should talk about how that's going to be carried through, how it's going to scale for future usage or future utilization of that program. Is the limitation is going to be the thing that you're going to come back to that's going to talk about the scale. Okay, so the scope of this, and then if you have any kind of resources for documentation that you would put in there. So I would put something like, the reference, the project requirement. So you can say, refer to project requirement documentation, and also LC-3 specifications, or if there's any publication you want to refer to that there. Okay. Now, developers, when they work on this, they might have to refer to other documentations, right? Other applications, other web interfaces, and so on. So they would then they would list those here. Okay. Then the companion application requirement documents what other documents should be reviewed with this document. Okay. So if you don't have any other documents, then you can just put, none there or not applied. That's fine. The overall description. So here you would also list your objective, but be descriptive. Okay. Like how the program should be used, right? What kind of things that you need in order to use it, right? You know that we need LC3 simulator in order to do that. And then, the program, you should say the program should be loaded into LC3, right? And then if there's any kind of input area, you would need to indicate that, right? Input at location here, here, and here, refer to the fill section of the code, etc., and so on. Okay. So this is just like a brief example of it, but you wanted to include, right, as much information about your product as possible in, a paragraph. All right. Next, you're going to talk about the functionality. So this should describe your algorithm, your procedure in the program, the steps that the program goes through. Okay. So just summarize that. What is your program to do, right? How is it adding the numbers, or, for the grade calculation program, right? The program is to calculate average, minimum, highest grade, etc. How is it converting that to be able to display the grade in letter grade and numbers? Okay, so talk about the functionality of your program there. Okay. And if you wanted to include the technical functionality, tie it back to LC3 on how you use your registers for, to calculate, or how you would incorporate function calls, etc. Okay. So the technical area is your way. It should be the area where you would expand about the programming piece of it, where the earlier part should talk about the mechanism of the program. Okay. For the user class, I put down here that who are involved in the development of this process, including business, technical personnel, and their tasks, because they are stakeholders. Okay. And so if it's just you and your team members, then you would then include that, right? But in the development cases, you would then go back to it depends on the model that you would use. If you use Agile, you would then regularly communicate it with your client, and you would then modify your program as you go. But if you use waterfall model in development, then you would wait till the end, right? You beta test it, then you bring it to the client, and then you would say, okay, here it is, right? And if they don't like it, then you have to go back and redesign again, or, fix the things and add the things that they want. So, here is where you would state the involvement of those stakeholders. So in your case, you would just say how your team members would, work together, and then one would test certain part, the other one will be able to cover. And then if you involve me in it, you can just include that in this part of the documentation. Okay, or clients, and so on. So here what they did was they list the group of people that's involved and what those people are doing. Okay, to really give them the overall program design. Operating environment, right? This is super simple. What kind of application needs to be used with that particular program? What operating system is it running on? So we know that it can run on Linux or Unix and Windows, but mainly Windows. And then if you can also mention that we use LC3 simulator that's online for our program, right? So you should indicate that as well, because somebody can use that to test and run your program. Okay. And the development platform, you can mention LC3 editor there. Here is usually I look at your objective, I look at some of the areas. This is the area I usually go to when I grade this. I look at this to see if you put in the proper constraints and limitations, because here is where you need to include your screen capture of your tests. I had asked for that in the program, the requirement itself. So you should test, and you should test it to the limit, right? Is it going to handle 3 digits? Is it not handling 3 digits in the grade calculator? You know, or there's some issues with your program. I need to know that here. Okay, because with this, what we would do is we would be able to make recommendation for future improvement, and we can think about the areas that we want to scale our program. Okay, every application has potential improvement. Okay, there's no perfect system. All right, assumption and dependencies. Okay, so you need to include any kind of dependencies. Meaning, what do I mean by this? Is there, here, if you look at the example, it says, assume that if the data is made available for the project in the phase of the completion, unit test data will be used in providing the demo and the presentation. It's assumed that the user is similar to in an internet browser and similar with the handling of the keyboard and the mouse. So assuming that your user knows LC-3, they would know how to use the simulator in order to run the program, right? Assuming that they would have the LC-3 application, so you can put that. You can make the assumption, and so the dependency of the usage of this program is really with the simulator, right, and understanding LC-3 itself or that particular architecture, okay? So that needs to be put here. External interface requirements. So you can talk a little bit about the user interface, and we're using the console to interface with the user, right? And the user is going to use the mouse and the keyboard to input the data, right? Their data into the system where your program is going to be able to, you know, if it's a grade calculator, then it would calculate the grade, but then it has to ask for the input. Hardware interface, you can talk about hardware, specific computer type, terminal types, mouse, keyboard, your input devices. Software interface, talk about your OS, which you probably have mentioned in the past, and LC-3 simulator. Okay. Let me see. Here is where you need to give me your subroutine information. Okay. The purpose of your subroutine, how you use your input output, and how you store your data. So be more specific. So whatever you pseudocode, put it here, not the pseudocode itself, but put it into like paragraph format. Okay. You can say that, you know, here, these are the subroutines, and this is going to be their purpose. The input, right? How you ASCII convert. And, you know, for the grade calculator, you would say that there are, you know, let's say 5 different inputs that's recorded from the user. Each individual input is ASCII converted. Okay. And then how it would be stored, and then how it would be calculated. Is there, you know, save register process that's happening there? And then what will be the output at the end after it calculates with the other, using the other subroutine. Okay. So here, make sure that you address the question in red. And the proper way that they do this is you would do it like this: the purpose, the input, the processing, the output. Okay. So for every, you know, if you return from the subroutine, how that's used to be, that's brought into the next subroutine, right? And then, and so on and so on. Now, if you come into a section that doesn't apply, you could just remove it, okay? I put here for the analysis requirement, and in that, you would want to analyze, right, the overall program the processes behind it, the input. But if you don't have the analysis requirement, you can just remove it. Okay. For performance requirement, how is your program expected to be performed, right? And when you look at how you incorporate functions, that really tells you how you approach the program. Um, with the algorithm, that's going to be how your performance is going to be. And if you've taken 17C, right, I know Dr. Lair goes in detail about this, looking at your program, but if you haven't, that's okay. You know, if you're using recursion, that's different than iterations. If you nest loops, if you're using like binary tree approach, that's different. So do your best in evaluating this part. Okay. Think about how you're using storage, how you use your subroutine, how you use your register, and that kind of tie back into, space time, correlation for your performance. Okay. And then the last part, please include pseudocode, flowchart, etc. Okay. Now for this class, I think I mentioned that you would do flowchart and pseudocode. So if you can use online program, if you pseudocode it in some program, you can just import that in, and then it should be able to chart most of it for you, but you have to fix it. Okay. Or you can do the flowchart and then take it out piece by piece. Now, I don't want to see code and pseudocode. Please do not give me code and pseudocode. Okay. When I see that, it's frustrating because then I would see that you code it and then you put it into pseudocode by copy and pasting. That's no good. I see a lot of that in my Java class, my Python class. So I don't want to see it in this class. Okay. So make sure that we don't have code in our flowchart and in our pseudocode. And your flowchart should have a start and a finish. And everything that you branch, every conditions, every iteration, you need to include it in pseudocode and flowchart. That's something that I look for closely. Many students do pseudocode incorrectly and flowchart incorrectly. And if you want to learn how to do pseudocode better, there is a non-credit class this summer that's taught by one of my adjunct faculty. He's pretty good. Then you can take, and non-credit, you don't have to pay for it. And it's really short. It's like 2 weeks. Okay. So you can take it, you can learn how to do pseudocode better. Okay. And it's a whole series. So if you take the whole series, you can get a certificate out of it. It's designed for like pre-computer science or just to brush up some of your skill in computer science. Okay, any questions? Okay, so
And this assignment, it's due by the end of next month, right?
yes, it's due when you turn in your project. Okay. So this is part of the actual project itself. So part 2. And so when you turn in your project, your program, you should turn in your documentation. You can put everything into a zip file, or you can just upload it as a document. I think your ASM file is going to be tiny anyway, so you don't have to zip it, right? I'm not one of those faculty that requires zip folder, because it doesn't matter with me. The only reason why that sometimes I would require zip folder is when you try to write packages, like for Java classes or for classes that require you to write module and packages, you have to organize things in the proper directory or folders. Then yeah, at that time you can do an actual folder and zip it. But if you zip it, I don't mind. If you don't zip it, it's okay too. So you should provide me with the documentation and the assembly program. So when you look at the course project, it tells you right here, this one, okay? So for part 1, I'm sorry, this is actually for the part 1. So the documentation is going to be 70 points. Okay. And if you don't complete the whole document and you try, right, your team tried, you just ran out of time or whatever it is, you should still turn it in. Okay, I'll take it. Partial credit is better than none. And sometimes that helps a student between a B and an A or whatnot. And then, you know, your team task assignment, the 30 points, I would look at the shared Google Docs and then I would put in the points accordingly. Okay. And then the program itself, you know what, so this is due on June 10th. I think I'm fine with that. Okay. So part 2 is due on June 10th. And you should go through the rubric and use it as a checklist, the requirement list. Make sure that you hit every single area. Okay. If you don't, then you just lose the portion of the points for that. Oops. Okay. Let me double check something before I go to the next one. And I already talked about part 3. Okay. And then when we have more time, I can show you if in case you have a hard time doing your e-portfolio. So I'm going to change the due date for part 1 before we go. Okay. So I know that I put down the 18th, but I highly recommend in the next couple of weeks, since we're still meeting in class for lecture and things like that, make sure that you identify the people that you want to work with. Maximum of 3. Okay, at least 2 people in the team, and then 3 is the max that I'll take. I'm gonna go ahead and change this to the 25th. So that gives you like close to a month to get this done. Part 1, documentation and setting up your team. Okay. But don't wait until the 25th to really start your project, because then you only have like 2 weeks to work on it. And if there's problem, then you can't fix it. And then other class would require time and so on. So if you have questions, please reach out to me and let me know. If you want me to take a look at your program, I can take a look at your program and give you some feedback. I will not fix your program for you. However, I can kind of identify some area. I would point you to it and say, you know, maybe you should do this. You should fix this right here, this section. Okay. Or, you know, like earlier, I had office hours and one of the student came in and he asked me to look at his program. I'd be happy to do that. And I would say, okay, this is missing. You can add this, maybe you can add this. And so that way it helps you, you know, clear up some of the issues you have. Okay. Is data sanitization a requirement? No, but I would consider, so I would grade the program itself based on the rubric. And so if you look at the rubric, let me go back to that. Okay. I didn't include too much as far as like, you know, the performance area or sanitization area and whatnot. I basically, these are the objectives that we hit throughout the semester in the lecture and the lab. So I wanted to make sure that, you know, technically you have the capability to achieve these. So that's why, you know, I wanted to include that, but not the other areas. So no. If you implement it, that will be a plus, but not necessarily required. Okay. Anything else? Okay. Now, you know that other students probably had posted stuff online. And this is, you know, I sometimes update my project, but I do check if people copy and paste code. Okay. So if you copy and paste other students' project, it would be an automatically 0, sometime drop from the course. last the fall semester, 2 teams turned in almost the exact code in my Python class. And, they didn't even rename the variable. They did rename the functions, but it looks exactly the same. So when I graded it, I looked at it because I do read all the code, and I sometimes run checker on it. And if it matches exactly, or it matches internet sources, it's an automatically 0. And then all of these write-ups and things like that. So I don't want that to happen, right? You deserve to earn a good grade in this class. And so do your own work and program it, okay? And if you need help, just reach out for help and ask questions if you have a hard time understanding something, or, but I want you to attempt it, okay? If it is incomplete, like I said, you still should submit it, okay? Just don't just like ignore it, and then it will just be an automatically 0. So at least it's something in your grade, and that's important. Okay. All right, type your name into the chat. I'm sorry I went over once again. Have a good night. I will see you Thursday. We are doing the last lab on Thursday. Okay. Thank you. Good night.
Good night, Dr. K.
Bye. Good night, Ryan. Good night,
All right, good
everyone.
night.
Good night. Bye. Thank you. Good night. Thank you. Have a good night.
Hello, Professor.
Yes.
Will you be available for your office hours on Thursday?